is a loop of arteries. The circle of Willis, or cerebral arterial circle, is a loop of arteries at the base of the brain. This loop is going to allow for redundant blood supply, or a backup route known as collateral circulation. And the theory behind this is that if one vessel becomes blocked, there would be an alternative route around the circle to reach the area that would have been supplied by that vessel directly. So theoretically, with slow occlusion of one of the vessels, the circle of Willis would provide an alternative way for the blood to still reach all aspects of the brain. Now, let's say there was a stroke or something that happened really quick, or an aneurysm, and blood loss would then result to a certain area of the brain. Now, we wouldn't automatically have the blood compensated for with that lost vessel, but in slow filling or occlusions of the vessels with atherosclerosis, it could be possible to provide a backup blood supply to all aspects of the brain through this arterial circle. Now, the major contributions to the circle are going to be provided by the two major inflows of blood to the brain. The anterior route of blood to reach the brain is the internal carotid artery on both the right and the left sides. So we're going to have on the left side of the skull an internal carotid artery ascending up to this loop, and on the right side of the individual's skull. Now, the internal carotid artery is a major blood vessel that is going to supply the anterior and lateral aspects of our brain. And the major vessels branching off of this that I want to highlight are the middle cerebral artery and the anterior cerebral artery. So the internal carotid artery is essentially going to split into a branch that goes laterally out towards the parietal and temporal lobes, and an anterior branch that's going to go towards the frontal lobes. The right and left sides are going to be connected by a small vessel known as the anterior communicating artery. And this is really what's going to connect the right and left sides' blood supply anteriorly within our brain. The other route for blood to come into the brain is through the vertebral arteries, again paired right and left. These two vessels are going to ascend up through foramen magnum with the spinal cord, and then they merge together to form a vessel known as the basilar artery. Now we can see that there are multiple branches coming to the cerebellum and brainstem off of the basilar artery, as well as the vertebral arteries. However, I'm not concerned with memorizing those at this time. The basilar artery is going to be the midline unpaired vessel formed by the junction of the right and left vertebral arteries, and it's going to terminate as the posterior cerebral artery. So we've now seen that there was an anterior cerebral, a middle cerebral, and now a posterior cerebral. And this is going to go back towards the occipital lobe. Now, the communication between the anterior blood supply from the internal carotid artery and the posterior blood supply from the vertebral arteries is through the small posterior communicating artery. So we can see that the posterior cerebral artery will now be connected to the internal carotid artery near the junction or splitting point of the middle and anterior cerebral arteries. So the posterior communicating and anterior communicating arteries are the key vessels to make this loop function.